Hi everyone. We uh, we discuss today the principle of spectroscopy. What's meant by principle? Principle is based on the measurement of a spectrum of the sample containing atom molecules. Here, measurements of spectrum of the sample. Here, the sample interact with electromagnetic radiation. Different interaction, maybe absorption, maybe emission. Different interaction with electromagnetic radiation produce a spectrum. From this spectrum, the spectrum is a graph of intensity of absorbed or emitted radiation by the sample versus frequency or wavelengths. Here, intensity is spectrum graph of intensity of absorbed or emitted radiation. Absorbed or emitted radiation produced from interaction with the sample of the sample and electromagnetic radiation. The interaction between the sample and electromagnetic radiation produce absorbed or emitted radiation. The intensity of this absorbed or emitted radiation can be dropped versus the frequency of or wavelengths. So the intensity of absorbed or emitted radiation versus the frequency or wavelengths produce spectra. This spectrum used for qualitative and quantitative analysis. A spectrometer is an instrument designed to measure the spectrum of a compound. A spectrometer is an instrument. They have different instruments produce different part of electromagnetic radiation, and so there is different interaction between the electromagnetic radiation and the sample. Firstly, this is absorption spectroscopy, analytical technique which concern with measurement of absorption of electromagnetic radiation. When the sample interact with electromagnetic radiation and this sample absorb part of energetic photon, this absorption is measured by absorption spectroscopy, like UV, like visible, like IR spectroscopy. This is concerned with the measurement of absorption of electromagnetic radiation. There is a emission spectroscopy, analytical technique in which the emission of particle or radiation is dispersed according to some properties of the emission, and the amount of dispersion is measured. Some material interact with electromagnetic radiation, and instead of absorb this electromagnetic radiation, can absorb part of electromagnetic radiation and emit it again radiation like photon. This emission can be measured, and this is analytical technique concerned with measuring this emission. It's called emission spectroscopy, like atomic emission, like fluorescence. This is different part of spectroscopy called emission spectroscopy. Interaction of electromagnetic radiation with the emitter or the sample. Interaction of electromagnetic radiation with the emitter. This one, electronic energy level. At room temperature, the molecules are in the lowest energy level. اللي هو في level the lowest energy level, in stable one. When the molecule absorb light, one of the, namely UV visible light from electromagnetic radiation, one of the outermost bond, اللي هو lone pair of electron, is promoted to higher energy states. Transfer of this electron from the lowest energy state to the highest energy state. This is called electronic transition. So when the sample produced in E1 or sorry in E0, E0 is the lowest energy level. There is no energy. So when we introduce the electromagnetic radiation to the sample, this sample absorb energy, and sample transfer from energy 0 to energy 1. This is called electronic transition. This is called transition. Electronic transition because the electron transfer from energy 0 to energy 1, because this electron absorb energy from electromagnetic radiation, so this electron become unstable, so they are go to the highest energy level, to higher energy level. Like there is many طبعا energy level E1 E2 in is called electronic transition. And the difference is different in energy. This is the different energy between E0 and E1, or any En each V equal En minus E0, and this is the difference in energy. This energy different in energy can be between 35 to 71 kilocalorie per moles, and this energy can be provided by UV part of electromagnetic radiation. So the UV part of electromagnetic radiation, when absorbed by the molecule, the electron from the lowest energy level transfer to higher energy level and produce absorption of electromagnetic radiation, and this absorption can be measured to calculate qualitative or quantitative data. Number 2, vibrational energy level. These are less energy than the electronic energy level. These are less energy. The spacing between the energy level are relatively small, 0.01 to 10 kilocalorie per mole. This is low energy compared with electronic energy level. In vibration energy level, there is no electron transfer, no electronic transition, but this is just vibrational. The molecule become vibrated, rotated, vibrational to different in space, vibrated in space, because it absorb energy and become unstable, so it's vibrate. This molecule vibrate, so it's called vibrational energy level. When the IR radiation is absorbed, the molecules are excited from one vibrational level to another, or it's vibrate with the highest amplitude. So when this is here, the vibration caused by infrared radiation part of electromagnetic radiation, which is low energy compared with UV radiation. Here 0.01 to 10 kilocalorie per mole, which is low energy compared with electronic energy. Here's just the molecule vibrate in space. This is called vibrational energy level. The third one is rotational energy level. These energy levels are quantized and discrete. The spacing between the energy level are less smaller than vibration, so rotational, just molecule rotated about herself. The molecule rotate, just rotate here, rotate, the molecule rotate. So this is the lowest energy compared with vibrational, the smallest, and the space between the energy level are even smaller than vibrational energy level. So different in energy: electronic high, vibrational low, and rotational is the lowest energy. Different between spacing. In some molecule and atom, photon of UV and visible light have enough energy to cause transition between the different electronic energy level. So molecule, atom, and there is a photon of UV light, and this molecule absorbs this photon and cause transition between different electronic energy level. The wavelength of light absorbed is that having the energy required to move an electron from a lower energy to higher energy level. So when the energy provided by this photon equal to the different in energy between the lowest and the higher. So this molecule can absorb this energy and transfer from lower energy level to higher energy level. This transition should result in very narrow absorption band at low at wavelengths, result in a narrow absorption band at the wavelengths, highly characteristic of the difference in energy level of absorption is this is the rule for atoms. So we have to discuss this in detail. Okay. So this is the lowest electronic level. Okay, this is high electronic level. This is vibrational energy levels, and the blue is rotational energy level. Okay, so the difference in energy between E1 and E2, this is electronic and this is electronic. Difference in energy is the high. So this is the lower energy level and this is the higher energy level. The difference between them is the high compared with this vibrational. This vibrational is the difference between vibrational energy level is low compared with electronic, and this is rotational. Rotational also the difference between the different rotational is this is the lower energy electronic energy, and this is electronic energy. This is the vibrational, this is the vibrational, this is vibration, and the blue is rotational. Look here, when we supply this, introduce so this molecule higher energy, the electron transfer from lower to the highest. Okay, this is electronic transition. When the energy less, the molecule mean one vibration from lower vibration to the higher vibration. Lowest energy rotational, from lower rotational to the higher rotational. So when we introduce high energy cause electronic transition. So this electronic transition included different vibrational and rotational transition. Why? Because this is the higher energy, this is the highest energy compared with the vibrational and rotational transition. So the vibrational and rotational transition included with electronic transition. So the band here in UV, which is electronic transition, it's not sharp band, it's broad band. Why? Because it's included many vibrational and rotational transition with it. Not only electronic transition and just one. No, it's included many vibrational and rotational transition. So it's called broad band rather than sharp one. Clear?